Bismillahirrahmanirrahim. Now, this second video lecture is the continuation of my previous first video lecture of week 11th for the course Biostatistics 1. In the first video lecture, we have learned about the laws of probability. Now, in this video lecture here, some numerical problems of probability related to that laws of probability which we have learned already in the previous first video lecture of week 11th. For example, we have a problem that what is the probability of drawing a black card or a king card from a well shuffled pack of playing cards. Now, in this problem, there are 52 cards in a pack, so the number of outcomes in the sample space will be equal to 52. Now, let A be the event that the draw card is black, and B be the event that it is a king card. In this problem, actually, we have two choices: black card or king card. So what will be the probability of drawing a black card or a king card? Now in this problem we have R option. So for the R option we use the union between the two events A and B. For example, A is the event of our choice, that the card is black card. B is another event which contain our second choice, which is king card. So we need to find the probability of A or B. So for the R option we use the union, probability of A union B. And now since these two events A and B are non-mutually exclusive event. In case of non-mutually exclusive event, the probability of A union B will be equal to probability of A plus probability of B minus probability of A intersection B. Now since there are 52 black cards, 26 black cards, so the probability of A will be equal to 26 by 52. There are 26 black cards, 4 king cards and 2 black king cards in a pack. So we have the number of outcome in the event A is equal to 26 and the number of outcome in the event B is equal to 4. Now number of A intersection B is equal to 2. A intersection B is the intersection of these two events A and B. So in case of 26 black card and 4 king cards, in these two types, 2 black king cards, so the probability 2 black card, 2 card will be black as well as will be king cards. So A intersection B has 2 outcome. 2 outcome are common in these two events A and B. So the probability of A is 26 by 52, probability of B is equal to 4 by 52, and the probability of A intersection B is equal to 2 by 52. So putting these values in this law, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This is 26 by 52 is the probability of A, 4 by 52 is the probability of B, and 2 by 52 is the probability of A intersection B. Now after simplification we have 28 by 52 which is equal to 7 by 13. So the probability of A or probability of B is equal to 7 by 13. Now another problem, a pair of unbased dice is thrown. To find the probability that number 1, the sum of spots is either 5 or 10. Number 2, either there is a doublet or a sum less than 6. Now for the solution, since the first die can be thrown in 6 ways and the second also in 6 ways, therefore both can be thrown in 36 ways. Fundamental principle of counting. This is called fundamental principle of counting. Since both the dice are given to be unbased, so 36 elementary outcomes are equally likely. Now for this case, the sample space contain all these possible outcome. These are the possible outcome of this experiment, that a pair of unbased dice is thrown. So a pair of unbased dice. So in case of pair of dice which thrown one time has all these possible outcomes. Suppose we have fixed result on the dice for the uh, first dice, and the result of the second dice will be vary. So we obtain 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, and maybe the result for the first dice is a fix, which is 2, and the result of the second die may be vary. So we obtain these outcome 2 1, 2 2, 2 3, 2 4, 2 5, and 2 6. Similarly, we have all these other outcomes. Now let A be the event that the sum of these parts is 5, and B is the event that their sum is 10. Since in this case we have to find the probability that the sum of parts is either 5 or B. Now we have R option. In case of R option, we use the union. So thus we can write A is equal to A is the event in which the sum of this part is 5. So in this event we have these outcome from the sample space 1 4, 2 3, 3 2, and 4 1. And similarly, B is the event that the sum is 10. So for this case, the event B contain these outcomes from the sample space when the sum is 10, 4 6, 5 5, and 6 4. The number of outcome in the event A is 4, so the probability of A is 4 by 36, and the number of outcome in the event B is 3, so the probability of B is 3 by 36. Now note that these two events are mutually exclusive. There is no common outcome between these two events, so the probability of A intersection B will be equal to 0. And by using the addition law, probability of A union B. Why we use addition law? Because in this problem we have the R option. In case of R option, we use the union symbol, and this term will be 0. Probability of A intersection B will be equal to 0 because A and B are disjoint sets. Now the probability of A union B is equal to probability of A plus probability of B. So probability of A union B is equal to, putting the value of probability of A 4 by 36 and probability of B is 3 by 36. Now after adding we have 7 by 36. So this is the probability of A or B, where A is the event which contains the outcome when the sum of these parts is 5, and B is the event when the sum is 10. So the probability of A or B, probability that the sum is either 5 or 10. Now another part for this problem, let C be the event that there is a doublet, and D be the event that the sum is less than 6. So we have for the event C, the outcome are 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. C is the event that there is a doublet, and now D is the event that the sum is less than 6. So D event contain these outcomes 1 1, 1 2, 1 3, 1 4, 2 1, 2 2, 2 3, 3 1, 3 2, and 4 1. Now further, since these two events has two common outcomes which are 1 1 and 2 2, so C intersection D contain these outcome. So number of outcome in C intersection D is equal to 2. So C and D are non-mutually exclusive event. So the probability of C is equal to 6 by 36, probability of D is equal to 10 by 36, and probability of C intersection B is equal to 2 by 36. Now by addition law, we have probability of C union D is equal to probability of C plus probability of D minus probability of C intersection D. Now putting the values, probability of C 6 by 36, probability of D 10 by 36, and probability of C intersection D is equal to 2 by 36. Now after simplification, we have 14 by 36, which is equal to 7 by 18. Now another problem, a card is drawn from a pack of 52 cards. To find the probability of getting king or heart or a red card. Now in this problem, we have three choices: king card, heart card, and red card. But we have the R option for these three choices. So we will use the addition law. For the addition law, we use the union, and we replace the union by addition. Let A is the event getting a king card, B is the event getting a heart card, and C is the event getting a red card. Now A, B, and C are not mutually disjoint events. So we are interested in the event A union B union C. So we have probability of A is 4 by 52 because A is the event of king card. So king, there are 4 king card. So probability of A is 4 by 52, and probability of 4 by 52 is equal to 1 over 13. Probability of B is actually the event of heart card. So 13 by 52. There are 13 heart card. So and 13 by 52 is equal to 1 over 4. And B is the event which contain the outcomes getting a red card. So there are 26 red cards. So probability of C is equal to 26 by 52, which is equal to 1 over 2. Now probability of A intersection B is equal to 1 over 52 because there are only one outcome between there is only one common outcome between A and B, and probability of B intersection C is equal to probability of B, which is equal to 1 over 4, and probability of A intersection C, which is equal to 2 by 52, and probability of A intersection B intersection C is equal to 1 over 52. Now by using the addition law, we have probability of A union B union C, which is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of A intersection C minus probability of B intersection C plus probability of A intersection B intersection C. So putting the values, we have 1 over 13 plus 1 over 4 plus 1 over 2 minus 1 over 52 minus 1 over 4 minus 2 over 52 plus 1 over 52. Now taking the LCM, we have 4 plus 13 plus 26 minus 1 minus 13 minus 2 plus 1 divided by 52, and this is equal to 28 by 52, which is equal to 7 by 13. Now another example, consider the family has 3 children. What is the probability that number 1, family A has the children of both sexes, and B part, family B has at most one boy, and to show that A and B are independent events. Now for the solution, the family has 3 children, so the possible outcome for the sample space will be equal to B B B, double B G, B G B, G double B, B double G, G B G, double G B, and triple G, where B mean boy and G mean girl. So the number of outcome in this sample space is equal to 8. Now let A is the event. The family A has the children of both sexes. So For this description, the number of outcome for the sample space will be equal to the family A has the children of both sexes. Of both sexes, this outcome has both sexes. This outcome, this outcome, this outcome, this outcome, and this outcome. So there are six possible outcomes for this choice. You see over here: double B G, B G B, G double B, B double G, G B G, and double G B. Now the number of outcome in this event A is equal to 6. So the probability of event A is 6 by 8, which is equal to 3 by 4. Now another choice, the family B has at most one boy. So this event B at most one by boy. For this description, the number of outcome for the sample space will be B double G, G B G, double G B, and triple G. Family B has at most one boy. So the event B has four outcomes. So the probability, the number of outcome in the event B is equal to 4. So probability of B is equal to 4 by 8, which is equal to 1 over 2. Now these two events has three common outcomes: B double G, GBG, and double GB. So A and B are non-mutually exclusive event. And the number of outcome in the A intersection B is equal to 3. So probability of A intersection B is equal to 3 by 8. Now dear students, note that in this problem actually we have the AND option in our choice. We have the AND option. The probability family A has the children of both sexes and family B has at most one boy. Consider the family has three children. What is the probability that family A has the children of both sexes and family B has at most one boy? In this case, actually we have the AND option to find the probability of A and B, and we need to show that A and B are independent events. So for this case we use the multiplication law and multiplication law of two independent events. So probability of A intersection B is equal to probability of A dot probability of B, and A and B are non-mutually exclusive event. So probability of A 3 by 8, and this 3 by 8 is actually probability of A is 3 by 4 and probability of B is 1 over 8. So this is equal to 3 by 8. So the left hand side, the right hand side are equal. So this means that A and B are independents. A and B are independent events. Now another problem, consider the family has 4 children. What is the probability that family A has the children of both sexes and family B has at most one boy? To show that A and B are independent events. Now in this case, the family has 4 children. So the possible outcome for the sample space will be equal to. This problem is similar to the previous example. In the previous example, we have that consider a family that has 3 children. In this problem, the family has 4 children. So there is only one difference between example number 4 and example number 5. So the sample space will be different for both problem. In the previous example, the number of outcome in the sample space is 8. Now the number of outcome in the sample space is 16. In the previous example, you see over here the number of outcome in the sample space is 8. So in this problem, the number of outcome in the sample space is 16, because when a family has 4 children, there are these possible outcomes: B, 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 and B. Maybe all children are boys. Maybe 3 children boys and 1 children is girl. Maybe 2 children boys, third children is girl and the fourth children is boy. And similarly, maybe the first child is boy, second child is girl, and last two child are boys. And maybe the first child is girl and the three children are boys. So these under these descriptions we have all these possible outcomes for the sample space of this experiment, that when the family has four children. So in case of four children, these are the presentation, these are the arrangement of the children, that maybe all children are boys, maybe the first three children are boy and the fourth child is a girl. Similarly, maybe all children are girls. So these are all possible outcome for this experiment. So this is the sample space. In this case, the number of sample space is a number of outcome in the sample space is a 16. Now this is our choice. Family A has the children of both sexes. Of both sexes, for this description, the number of outcomes for this choice A event will be B, 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 and G. And this outcome, both children, the children have both sexes. And similarly, in this outcome, children are both sexes. And this outcome, children are both sexes. So these are the possible outcomes for this event A from the sample space when children of both sexes. Now the number of outcome in this event A is equal to 14. So the probability of A is equal to 14 by 16, which is equal to 7 by 8. Now the family B, at most one boy, for this description, there are possible outcome for the sample space for this event B, which are B, G, G, and G, G, B, double G, B, G, triple G, B, and G, 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 and G. This is the outcome in which at most one boy. At most one boy, that we select that outcomes in which there are no number of boys greater than one. At most one means that number of boy does not greater than 1 and less than 1. Number of boy does not will be greater than 1 but will be equal to 1 or less than 1. At most 1. At most 1 mean number of boy will be equal to 1 and less than 1. Less than 1 mean maybe. Less than 1 mean not equal to 1. So we can consider that outcomes in which number of boy is 1 or not equal to 1 or less than 1. At most one boy. This description mean that select those outcome for the sample space in which there is exactly one boy or less than one boy. So it's mathematically it's mean that select those outcome for the sample space in which there exists exactly one boy and has no boy. So this outcome has no boy. So this is the mean of at most one boy. Now the number of outcome in the samples in the event B is equal to 5. So the probability of B is equal to 5 by 16. So dear students, I want to tell you again that at most one, this description at most one boy, this description means that select those outcome for the sample space in which the number of boy is exactly equal to 1 and equal to 0. So in this outcome you see over here the number of boy is 0. So the number of outcome in the samples in the event B is 5. So probability of B is equal to 5 by 16. Now A intersection B, these two event A and B, A is actually the event which contain those outcome of both sexes, and B is the event which contain at most one boy outcomes. Now these two events A and B have some common elements, have some common outcomes. this is the common outcome of A and B. This is the common outcome, this is the common outcome, and this is the common outcome. So the number of outcome in A intersection B is equal to 4. So A and B are not mutually exclusive event. And the probability of A intersection B is equal to 4 by 16. Now since A and B are not mutually exclusive event, so A intersection B is equal to probability of A dot probability of B. Now putting the values, probability of A intersection B is equal to 4 by 16, and this is equal to 7 by 8 dot 5 by 16, which is equal to 35 by 128. So in this case, these two events are not independent. So dear students, in this video lecture, we have discussed some problems related to the laws, related to the theorems of probability. One is the addition law of probability, and other is the multiplication law of probability. Now this is the end of this segment. Thank you. Allah Hafiz.